Hi there everyone, welcome back to part 2 of deploying a Windows Server virtual machine using vRealize automation and SaltStack configuration. If you've not already looked at part 1, I urge you to go back and check that out, where we basically looked at an overview of what is SaltStack configuration, got our Windows Server template prepped and ready for deployment with VRA and SaltStack Config, and then we did initial test deployment to make sure that our SaltStack minion deploys correctly and that we can configure it for data actions going forward. Today's session is going to be more hands-on and less upfront slideshows. So we're going to look now at some production use cases, especially ones that I was doing on a regular basis when I was a customer and a consultant out in the field. So this would be deploying that Windows Server image, adding it to the Active Directory domain, configuring Windows services for whether they're enabled, disabled, configuring local user accounts to be enabled or disabled, and that built administrator to be renamed. Obviously, the obvious one, deploying software, configuring things like remote desktop access, and then we're going to look at how we roll that up so that we can run all of these state configurations as part of our Windows deployment, and we're going to then add that into vRealize automation, deploy that. You can also follow along this video with the blog post, which explains everything in detail at veducate.co.uk/VRA/SCC. Oh, sorry, VRA-SCC-win-P2. Let's get started. Okay, so we're going to spend most of this session in the SaltStack Config interface, and what we're going to do is we're going to go down to the config header here, then we're going to open that up and we're going to go to File Server. So the File Server presents itself as what looks like a file server interface through the UI, but actually it sits within a database on the Saltmaster itself. So that's your vRealize SaltStack Config appliance, or those machines if you've set them up in a highly available environment and manually installed that yourself using the standard installation from the VMware documentation. You have two folders here at a top hierarchical level. These are called Salt environments. And what I'd recommend, especially when you're getting used to SaltStack Config up front, is that you use this base folder here by default. And there's a couple of reasons for that, and we're not going to cover all of those in today's session because it starts to take down some advanced concepts. But you do have the ability to create another Salt environment as well. And creating files in the file server is really easy. So we can click which area we want to save it in. If we do want to create that new environment, we can just type the name in there, click to add the item, and then when we save the first folder or file, it will actually create that there for us as well. I'm going to select base, so actually we can see that's now come up. If I refresh this, okay, so we're going to select the base environment to create our file from. And then from here, then we can just type out the path as if we're locating the path in Linux or Windows. If we just call this one, I'm just going to call this demo for the time being. And then you can create your files as you need them to be. And these files, predominantly in our environment, are going to be SLS files. So that's SaltStack state file. So .sls is the endpoint, so something like init.sls. But as well, if you're doing things like web config, for example, you could do web comp files and you can reference these files as well. So sometimes we need to copy files from the file server locally to the virtual machine, or to whatever your deployed instance is to configure those services or applications or whatever it may be as well. In my demo today, I don't have any of that, but again, know that that's available. And you can put here and select the type of file, and this basically so it knows the type of format that's going to be expected here. So we just change that to text, for example, if it's going to be a config file. When we create files, by default, Salt is always going to look in a hierarchy and always expects to see an init.sls file available, which means that whenever you reference applying a state file to an endpoint, you don't actually have to specify the full location. We could just specify this demo part of the folder name in the Salt environment of base, and it will automatically apply the init.ls file, and we'll talk a little bit more about that as we start to build things up as well. So we're just going to call this is a test, and we'll save that, and we can see it comes up as save successful. And if I open my folder location, we've now got this demo folder, and then we've got that init file as well. Obviously this won't work because it's not a real salt state location. I can also delete all of that, and when I delete all of that, because there's nothing else left in that folder location, it's going to delete that for me as well. If we open up our presence folder, this was the stop state that we applied in part 1, so that we enabled the reporting of the minion back to us as well. And then we can see what looks like a salt file up front as well in the environment to configure with. I've created a Windows folder. So again, if I just cancel out of this and then I click to create, so we've gone base, Windows, then folder names, something like AD join. Actually, see it started to autocomplete when I created it, init.sls, and then create and save that. But let's go into that AD join and that init.sls because we're going to start off. So this is a state file. The first line inside your state file here is the identifier of the state, and you can use that to reference elsewhere within the state file as well. The second command here is the salt state itself. So in the blog post, I've actually detailed links to each of these salt configurations and the website that those are linked to. And also you can get all of these on my GitHub page as well. So if we go to github.com/state-DLE, you will find that on my page. At the moment, it's not been published for public use, so I'm recording this video, but it will be available for you as well to get all of those files nice and easily to import. So the first thing we're going to do is we're going to set the server host name, and then straight away we're going to specify that name as a parameter within that salt state that we're applying. And I'm just going to quickly go to the salt documentation as well so that you can actually see this in play. So I'm searching this in Google, I'm just going to do salt and then the state name. That's pretty much going to take me straight into the project documentation here. And we can say for this salt state, it's under the Win system set of operations, the computer name, and the only input it takes is the desired computer name itself. And then the next one we're going to use, so I'm just going to quick go ahead of myself here, is the join domain. We've got a number of additional parameters here. So we've got the name of the domain we're adding it to, the username, password to authenticate to that domain, the OU that we'd like to place the computer object into, what happens if the account already exists, and do we need to restart the virtual machine. These two are Boolean, so they're going to either take true or false as well. And you can see here, it tells you it needs to be true to restart that machine. And you've got an example of what that state file should look like for this particular one here as well, which is great. Okay, let's go back to our file server. So what we've done straight away here is introduce something called Jinja. So Jinja is a template interpreter. I probably haven't quite described that correctly, which someone might shoot me for, but there is great documentation from the Salt project website to explain Jinja and how it works and the different control structures that are in place. But essentially what happens is Jinja is a form of formatting the file and computes the outputs or inputs or the data that should be there before it runs the state itself. So to get the name that we want the computer to be, we're going to get the grain of information from that minion, and we're looking for the ID field. So that's the virtual machine name as it's been added into SaltStack. And if you remember, that's going to be taken from VRA and generated because we generate that name as part of the machine cloud resource object. So essentially it's going to pass that through nice and easily for us. After that, we then move further down and we then start to set our join to domains. We've got that system.join_domain. We give it the name that we're connecting to. Obviously, when this server comes up, it needs to have DNS access. It needs to be able to resolve that domain name to add it. We're then going to set the username and password. Now, I could put this as clear text into the file again, but actually here again, we're going to use Jinja, and we're actually going to call this data from something called Pillar. So essentially, Pillar is a data source that we can store information into. So here, the first section of this is we're calling a salt command, and that salt command is pillar.get, and then we're telling it to find the AD join set of data, and we're looking for the variable of username and the variable of password. So I'm going to go into my pillar data here, and you can see straight away I've got a pillar of AD join, and then this needs to be JSON format. So we have the username configured in my Active Directory, and then that secure password being passed through as well. Anyone who has admin access into the SaltStack Config server does have access into the pillar data, so that may not be secure enough in your enterprise environment. There are other ways to secure this data and pull this configuration data in as well, but that does require some more thought and extensibility and maybe some architecture around how you do that as well. Again, if this is something you're looking at implementing in a production environment, you need help with that, then get in touch with VMware, and they'll be able to align you to the correct resources to help describe those options to you as well, to help you find the best way forward. So let's go back into this AD join and just finish off talking through that. So I've set that restart as true. Remember when we looked at the salt documentation, it told us that that needs to be in place with the boolean of true, so it restarts the virtual machine for that AD join to be successful. We're setting the account AU. And then the final piece that we'll put in here is something called the require parameter or argument. So this is a bit like when you do a CLI command and you have global options available to that CLI command, maybe like verbose output, for example, which is always a common one. We have require as well, that's available for any state. And what this is saying here is that for this set of state config here, because this block is that I'm highlighting is state configuration, and this is a separate state itself that we're passing through to the VM. We need to make sure that the required state happens before it, and that needs to be the set host name. And we can add multiple states to this as well if we need to in a list format. The other place I just want to finally call out here as well is indentation is very key. So it uses YAML formatting. So if you've ever used YAML formatting before, that's fantastic. You'll probably understand the necessary parts of needing to use indentations in the correct way. If you've not used YAML before, it's one of the areas that catches out people quite a lot. Essentially, the first line here, so the first line is going to be straight away. Second one's going to be two spaces in. This will be 4 spaces in, and if it's in the same list, it's always going to be 4 spaces. This one here then is going to be 6 spaces in as well. Once you're happy with this file, we'll click save. I'm now going to move to the next set of configuration. We're going to look at a remote desktop. So again, creating the exact same way. I've just decided to put these into different folders just to kind of give it a little bit of a hierarchy here as well. We're going to use the service enabled state to set our services in place here, and you can see that using the services one as well. However, what you'll also notice here is we've got a different type of statement that looks along the lines of that Jinja that I was showing you earlier. So what we've done here is we've created an if statement to check the minion that we're applying this to has a grain OS which equals Windows. So we're actually identifying up front before we apply this state that this is the correct operating system to be applying this to as well. And then we end that at the bottom with the end if statement. So essentially this is now becomes inside of a control structure, this data. So we could have multiple end ifs. We could also, for example, I've just removed the D word there. We could also as well add another one here, do %, and we could do an else command or an else if, for example, as well, so that we could maybe say, well, if it's not a Windows device, what do we want to do with this? At the moment, essentially, if we apply this single state on its own and it's to a Linux machine, nothing will happen because it's not for Linux. Going back to the configuration, so again, I've set my identification name at the top, setting service enabled, and then I'm setting services in place as well. And one of the things about where these services come from, I'll go and the names I'll go through in a moment when we get to the services section in more detail. But essentially what we're doing here is make sure it's enabled in the system, make sure that it's running as well. So it's actually started. And then the last thing that I'm going to do as well is I'm going to make sure that the following registry key is present. And if it's not present in the system, it's going to create that registry key for me as well. So let's move on to services. So we've got another init SLS file, so all these are the same so far. Again, we start off with that same control structure to check that it's a Windows machine we're applying it to, and then we're going to basically disable and stop the print service and one of the diagnostic Windows telemetry services within our server as well. So obviously one of the areas that might stand out to you is where do we get this service name from, because diagtrack isn't human readable and it's not quite called that inside the system. So if I just go my server here, go to the services MSC, we'll just do this by name, and I go to print server, for example. If I open this up, we're going to see that server name here is Spooler, so that's where we're getting the service name from. One of the other things that you could do, for example, is you could also list out the services through Salt itself to understand all of the names that are in place if you need to. Moving on, so we're going to go to the users next, and there is a reason why I'm skipping out software install, and I've also skipped out that baseline folder as well. So in the users file, again, we've got another control structure. And what we're doing here inside this control structure is we're actually setting a variable called rename admin. And then we're going to reuse that rename admin here. Now, in this file, we don't actually need to do that. I could just manually pass through the answer for this variable. However, we can also pass through variables from vRealize automation as well. So I thought it'd be kind of good to kind of earmark that out in this example in the blog post. But I'm not going to take through exactly all of those areas today. Maybe that's something we could do on a different day, but it's kind of to get you thinking about some of the power of SaltStack Config as well. So going back to this control, we're setting that variable called rename admin. We're then telling it to get the pillar data of rename admin. And then essentially I'm manually setting this because there is no pillar data up front called rename admin. So I'm providing that at the moment. However, if I wanted this to come through from vRealize automation, if I left that as empty, what's going to happen is when we run that state through VRA, it's going to see that as a variable attached to it called rename admin. And then it will populate that data for me as well with whatever we've passed through from VRA itself. In this one, I'm actually faking it because I'm just passing this through directly myself in the file. Again, we set the ID name for the state that we're going to run, the state configuration itself. We're then going to set that state that we're executing against, which is the local group policy set. Within there, we're doing the configuration of computer policy. We're then giving it what the GPO name is. This actually is the human readable name, which is rename the administrator account, and then we're passing through the configuration items that are available. So in this case, it's going to be that rename underscore admin control structure, which then basically goes back to this variable that's been set in place. The next thing that we want to do, so we want to look to see if this virtual machine has a domain role, and we want to see if this is a domain control that we're running this against. So in our environment, it's not going to be a domain control today, but I thought it'd be a good way to kind of show one of these if and else statements in place as well. So we're getting that salt system info. So it's not already a grain information that's stored by in salt by default. So we're calling a salt command called system.get underscore system underscore info, and we're looking for the return value on OS type. We then have an if statement that says if it's a domain controller, then we have again the ID, and then basically what we're doing here is a test NOP, which basically is an output, and the output will be this is not a Windows member server, so we don't want to disable the local admin account because that's the built-in one. That's actually the domain administrator as well. If it's not a domain controller, then we go to the else, and then we run this state instead, which is then to disable that administrator account in our environment. But again, I've used one of those requirement statements to make sure that we've renamed that admin as well. So just kind of make that change from a security perspective. Okay, so let's tackle the next biggest area, which is the software installation. So in the GitHub and on my blog post, I actually take you through two methods to install. You will see a third option or a third software install here for Malwarebytes. It actually follows the same method as the Firefox install, but with Malwarebytes there are some nuances. Please do go over to my blog post and check out debugging WinRepo with the Salt project to find out why that Malwarebytes was a little bit of an issue for me. So let's click into the Firefox one. So the Firefox installation is really simple. So we're calling a state called package.installed and then giving the package name itself, which is Firefox x86 for the 64-bit installation. And behind the scenes, though, there's quite a few things going on. So in the blog post, one of the things that I show you how to do is set up something called WinRepo. And what WinRepo is doing at a salt level essentially is recreating a method very similar to yum or apt for Linux to install software easily into a Microsoft environment. Let's just make this text a little bit bigger for everyone here as well. We're going to put that up to about 14 there. There we go, so that makes it nice and easy for everyone to see, and I'm going to make this a little bit wider for everyone to see as well. Okay, so to get ready for the installation of Win repo, we need to install Git on our system, so yum install Git. I've already done that on my platform today, and then we also need to do pip install Git Python as well. So we've got the Python modules for handling with Git. And then it's really simple. We're just going to run a command which is called salt run. So this means it's running locally, win repo, and then it's update Git repos. And what it's just doing is going out to the open source Git environment and populating these folders on our system using from Git, and then that enables us to use WinRepo. So when the salt states are called for package.install, package.removed, it then goes and looks up the files located in these areas. The NG stands for next generation. So this bottom folder here is actually legacy and typically isn't referenced or used anymore. So in my environment, let's have a quick look. So we're going to move into that folder and we're going to go to the oh, I've copied the wrong one there, so let's do repo ng salt ng. Next, by doing ls, we're going to see lots of different files in here for installing software. This is all community based. We're going to look at the Firefox one just to make life easy. So I'm going to go cat Firefox x86. And I should do .sls on here because they're all state files. But what's really important here is what happens inside of these state files. So in the Firefox example, the first thing that happens is there's Jinja in place to set the installation language of the system. And then we've got a for version, which basically lists all of our available versions that we can specify to download. So that's actually a parameter of part of the package install to go along with the package name. You can provide a version number, and then it will match it against the versions available in this file. And then depending on the defined version, which then comes from that Jinja from that for instance, it then says it's got an if comparing versions of how to handle that, how to set the display version, which is then to do with the full name. So that's around some changing in the display names that are used depending on the version that's installed of Firefox. And then it tells where to get that installation from. So what we can actually see here is that the version numbers are languages and version in the file name are replicated each time regardless of that version, which makes it really nice for Firefox to be able to iterate through different versions without lots of different code. But we've got the ability to do to set different code blocks for different versions as well if needed. We then provide an installation flag as well, and then we provide an uninstaller location and an uninstall flag as well, and whether or not we need to use MSI exec to install the files with, and if we need to reboot the VM once the software has been installed. And essentially then what's happening in package.installed as a state is it's calling through to WinRepo because it's a Windows system. It's looking for the package, so this Firefox x64. It's then finding the version. If we don't specify a version, it goes for the latest, the highest number of the version. Then, obviously, if we're using the install command, it's going to look at the installer and the installer flags. If we're using the remove, so package.remove, then it's going to use that uninstall location, those uninstall flags as well. And that's WinRepo in a very quick and easy nutshell. The alternative is we could actually create quite a lot of this manually. So I've provided a state file as well to do this in a slightly different way. So rather than using the WinRepo, especially if maybe your installation package isn't available in there and you're kind of not quite there yet with creating those things for WinRepo and still getting started, then you could use the other provided SaltStack configuration state file that I've put here. We've actually done it for Notepad++, so there is a WinRepo for Notepad++, but I thought this was a really nice and easy one for everyone to understand. So the first thing that we do in here is pretty well documented to begin with. We're looking to make sure it's a Windows system. We're looking to set the agent name. So that's what we can look up on the system and check that to see if the software is already installed. We're going to set a file target, so where are we downloading or copying the file to. One of the areas to call out here is we are actually using an escape character, which is \n, which then when the Jinja processes this file will cause it to put a line break in place because it computes that as an escape character. So to escape the supposed escape character, we can just do that by adding an extra backslash in there, which basically tells Jinja when it's processing it to not process this backslash n as a special escape character. File source here is HTTPS, the download location for Notepad++, but you can see up at the top here in the documented notes, you can use HTTPS, HTTP, FTP, S3, or the Salt file system as well. And then finally, any install commands to push through. So that's setting the variables, very similar to what we've talked about earlier in some of the other state files. We then go through, so we're checking to see if the agent is present. So is the software already installed? If so, then the respond with agent is already installed, or the software name rather. So what's happening here is we're doing a salt call to get the packages list from the salt minion. We're looking for a substring in that list, and then we're looking for versions list equals true in terms of formatting that response back to us. After that, we go through an else command. So if it's not available, so we see it as absent, then we're saying that it's not present, and we'll call out in those salt files that we're installing that. And then if we keep on going down here, we've then got agents already installed. If agents already installed equals no, which is set from the above, then we copy that file from our target, to our target location from our source. Do we need to verify that using a SHA output? I've put no here to make life easy for myself. And then the command to actually install that software. So it's the file target and then the install command, which is any variables that you need with that as well. And then essentially to clean up that installation, it's going to remove that file at the end as well. And we just end those if statements at the end as well. So really kind of simple when you walk through it. It looks like a lot of code up front, but it's not. In terms of making it really easy for us to call those software installations, we can create a init.sls file, and we're going to use a command called, or a parameter called include. And what we're saying here is include all of the SLS files in these locations. You're calling out the SLS names, but again, not adding the .sls there because of the way that the Jinja formats this. So again, if you go back to the blog post, we've got a link about explaining why that's the case as well. Essentially, any period used in these commands will be converted into a backslash. So actually, rather than backslash SLS, it would be computed as backslash SLS. Okay, so that covers the software install piece, and the final piece to talk about here is my baseline init, and it's going to follow very similar to the software install init.sls file. We're doing an include again, and I'm including all of my folder locations, and it's going to then use the init.sls files from each of these folders. One of the things that you can do if you are going across a salt configuration area, you can actually put the salt environment in like there. So you can see here referencing base colon, because all this runs in the base salt environment. It's actually not going to do anything or take effect here, so it's not a problem whatsoever. But I thought it was just a cool call out there as well. But again, if you're going to use salt environments, heed the warning of making it too complex before you become an expert with the salts as well. You know, keep it simple. And that's it. That's explaining all of my salt configurations. So I'm going to go back into my VRA environment now, which has logged out. So we'll quickly back in. And if we go to my salt-windows, this was one that I made earlier. It's the same as the salt base, but with a few couple of configuration changes. So the first one here is rather than specifying that presence file, I'm specifying the baseline.init.sls, which calls all of my other state files that I'm interested in. If I really wanted, I could add multiple state files here if I wanted. As you can see, they still complete autocomplete and it will run all those for me. Still running that in the base area as well. I've also added this command here, which is allocate per instance equals true. And I've also then done this inside of my virtual machine as well. And the reason for that is because I actually want to use a count in there as well. So you can see here in the middle, this now has become a multi-count property in the environment, which means that the user can specify how many virtual machines it's going to replicate that number up. But because we're then configuring multiple of the same virtual machines, we need SaltStack to ensure that it's configured against each of these virtual machines and adds into the system as well. So let's have a look at that in action. So if I go to resources, and we go, I think it's to, yes, to chicken as a deployment. So here's one that I made earlier. I click on this, I can see you've got two virtual machines deployed that are essentially the same. If I click on the SaltStack config, I'm going to see it's configured two minions here. I can see the state file that's applied as well. And if I go to the history, again, I can see where it's applied. And if I open up the show logs here as well and I skim through these, we're actually going to see two sets of logs. The minion deployment, and then we can see this is 273 as the VM name. It then does the state apply, and then if I look below here, we're also going to see 109 as that minion as well, because it's part of that targeting in that grouping. And then again, it does the state apply as well. And then I'm just going to take this job ID here to look in my Salt environment just to show you what happens from a Salt point of view. Obviously, each individual machine gets its own job ID from that particular side of things. So I'm going to filter by by job ID, so we can see that state apply. If I click into this, I can now see that 109 ending again on the VM. If I click into raw, I can see all of these states being applied. So we can start to see, we've got the MPP-exe for Notepad++ there. If I go down, we've got, the disabling the Windows telemetry as well. And I can also look at the high state side of things, which actually gives maybe a better formatting for this as well to see what's happened, what the returns are, what changes are in place as well. And that's it. That brings to an end kind of this video that sidles along the blog post. Thank you for joining me in this technical walkthrough of using vRealize automation with SaltStack configuration to deploy a Windows server. Please do check out the blog theeducate.co.uk for more content around vRealize automation and SaltStack.